So I like to start, continue 3.7 with this problem. It's kind of long, but let's read it. A particle moves according to a law of motion, and t, of course, is greater than or equal to 0. T is measured in seconds and s in feet. Find the velocity at time t. We've seen something similar last time. What is the velocity after 3 seconds? When is the particle at rest? When is the particle moving in the positive direction? Find the total distance traveled during the first 8 seconds. Draw a diagram, I'll explain. Find the acceleration at time t and after 3 seconds. Graph the position, velocity, and acceleration functions, and when is the particle speeding up and when is the particle slowing down. Okay, ready? I would like to choose either 1 or 2. Let's do 2 so you can do 1 because it has the answers in the back. Is that okay? Okay, so let's do 2 on page 233. So 2 on page 233. It gives us a function, f of t, which is 0.01 t to the fourth minus 0.04 t to the third. First question is, find the velocity at time t. What do I have to find? What do I have to do in order to find the velocity at time t? Yes, that will be the first derivative. Can anyone give us the answer? .04 times t to the third minus 0.12 t squared. There was no secret there, right? We know this, right? Yes, everyone? Perfect. Part B, what is the velocity after 3 seconds? 0.04 times 27 minus 0.12 times 9. So 0.04 times 27 and minus 0.12 times 9. Oh, I got 0. Measurement unit for the velocity, knowing that this is measured in feet and time is measured in seconds. 0 what? Very good, of course. Part C, any questions? Stop me, please. Any questions? Eddie? Okay, part C. When is the particle at rest? When? Of course. Right? We are at 0 when the velocity is 0. Very good. So 0.04 t to the third minus 0.12 t squared equals 0. Of course, I will divide by 0.04. And I get t cubed minus this divided by this is 3. T squared equals 0. How many solutions do I have to determine? And that depends on the degree. What is the degree of this polynomial? 3. So I have to have 3 solutions. I will definitely factor out what? Not divide. I cannot divide by t or t squared. But I will factor out t squared, and I get t minus 3. And now I have to have 3 solutions. And they are?
0, 0, and 3.
Very good. So the velocity of the particle is 0 at the very beginning, and it becomes 0 again 3 seconds later. Okay. Part D. When is the particle moving in the positive direction? Positive direction. When is the particle moving in positive direction? So the particle starts moving, and if its velocity is positive, the particle moves to the right. If it's coming back, it moves to your left, and the negative sign pops up. The velocity is negative. Also, When we throw a ball up in the air, that's a positive velocity. When it comes back, the velocity is negative. So all I have to do is study the sign of the velocity. So one more time, the velocity is, and now I cannot disregard any of that, so I will factor out 0.04, and then I have t cubed minus 3t squared. And of course, I'm going to factor out t squared and have the same thing. But this time, because it's the function, I cannot disregard anything. All factors have to stay. So in order to study the sign of the derivative, which is v of t, I know that since we just determined a minute ago that the velocity is 0 at 0 seconds and 3 seconds, I would like to know whether between 0 and 3 is positive or negative, and between 3 and infinity is positive or negative. All I have to do is just pick a number. If I pick a number like 1, please plug it in and tell me what is the sign of this expression. Negative. Pick a number like 4 and give me the sign of this expression. Positive. So I will say between 0 and 3, negative direction. After 3 to infinity, positive direction. Any questions on this? Is this okay? Do we understand this concept? Yes, Noah?
How do you stop at 0 and not go to negative?
Well, what it means is that it starts at 0, and yes, it goes in this direction. It doesn't mean that time is negative. It just goes back, and then 3 seconds later, it goes to the positive side. So we can jump, if you'd like, in order to see it. That is the diagram that they are talking about in part F. Why not? So the particle starts here at time equals 0, goes in the negative direction till t equals 3 seconds, and all of a sudden turns and goes to the right all the way. So at this point, it's time 3 seconds, and then all the way it will be positive. So this is in a negative direction. It's going to your left, and then at some point in time, exactly 3 seconds later, it turns and forever goes to the left. Is that okay? Okay, part E. Find the total distance. So the total distance will be determined, and they are asking us only between 0 and 8. Between 0 and 8. Even when the particle goes left or right, it doesn't matter. I still have to determine the distance. So one distance will be between second 3 and second 0, and then between second 8 and second 3. So the total distance will be the absolute value of s, not s, it's denoted by f, I'm sorry, f of 3 minus f of 0, when it goes to the negative direction, plus the absolute value of f of 8 minus f of 3. So regardless of the direction the particle is going into, it will always accumulate distance. If you come from home to school and back, it doesn't mean that one direction accumulates distance and the other one, when you go back, it erases, right? It's still adding up. It doesn't matter the direction. So now with the graphing calculator, I will punch in y equals this function that we have, which is, where was my distance function? 0.01 x to the 4th minus 0.04 x to the 3rd. And then with second and table, all I want is 0, 3, and 8. That's all I care about. So now I'm going to just copy those numbers. Oh, I'm sorry. I'm sorry, I'm sorry, I'm sorry. I'm sorry. Okay, so here's the function. Sorry, my apologies. 0.01 x to the fourth minus 0.04 x cubed. And after I put it in, I went to second table, and please don't do this to me. Okay, so I plugged in 0, 3, and 8. So the distance covered at 0, of course, is 0, because that's the function has t in all terms. At 3, it has negative 0.27. So it went this way and accumulated a distance of 0.27 feet. And then at 8, it went from 3 to 8, right? 20.48. So now careful how we put this in. So f of 3, the absolute value, is negative 0.27 minus 0 plus the absolute value of f of 8, which is 20.48, minus f of 3 minus plus 0.27. So this would give us the total distance. So let's determine the total distance. So this is the absolute value of negative 0.27, so that's 0.27. And here I have plus, they're both positive. So 5 and 1, I think it's 7 and 20. Please correct me if I'm wrong. Right, 65, yes. 75, correct. So this will be 21.02 feet. So between second 0 and second 8, the particle goes this way, 0.27 of a foot, and then that way, 20.75. Any questions? Next one, draw the diagram we already did. Find the acceleration at time t and after 3 seconds. So that's g. The acceleration is the first derivative of the velocity or the second derivative of the distance or motion law of motion that we have. Okay, so that will be, where's my raw velocity? Here it is. 0.12 t squared minus 0.24 t. Now they're asking us to find the acceleration at 3, which is 0.12 times 9 minus 0.24 times 3. So if you have this number, if not, I'll calculate it. 0.12 times 9 minus 0.24 times 3. I got 0.36. Measurement unit. Please correct me if I'm wrong. Measurement unit. Every rate of change has 2 measurement units. One coming from the top and one coming from the denominator. This is the rate of change of velocity with respect to time. So what is the velocity measured in? Feet per, yes, but then second squared because the denominator has another second in it. Is that clear? So the numerator is in feet per second. Everything divided by second over 1. When you flip the denominator, you get the measurement unit. Feet per second squared. That is the measurement unit for acceleration. Okay. Let's see what else we have here. Yes. When is the particle speeding up and when is the particle slowing down? Okay. So let me give you an example. Assuming we're flying from Baltimore to San Diego, and there is a headwind. The airplane can do 600 miles an hour, and there is a headwind of 100. What is our actual speed? The airplane can do only 600, but we have a headwind of 100. What is the actual speed of the airplane? 500. What if we come back now, and the actual speed is 600? The airplane can do 600, and there is a tailwind of 100. What will be the actual speed? 700. Is that clear? So if two forces are against each other, working against one another, the particle will slow down. If two forces are working together in the same direction. If they are both positive, then the particle is speeding up. If they are both negative, the particle will speed up. But if one is positive and one is negative, the particle will, that's it. So then we're going to create a table. So that was our last one, I. We're going to create a table for t. We're only interested between 0 and 8, the velocity, the acceleration, and decision. I already know that the velocity is 0 at 0 and 3. We already discussed that. We studied the sign of the velocity a few minutes ago. It's negative between 0 and 3, and it's positive beyond that. But we haven't discussed the signs of the acceleration. Here's the acceleration. I will factor out 0.12 t, and then I get t minus 2. Okay, when is the acceleration 0? Because I have, like I put for the velocity, I have to do the same thing. So acceleration of t is 0, means t equals 0 and t equals 2. So 0 and 2. Now I need to study this sign of the acceleration as exactly as we did with the velocity. Please pick a number in between the zeros, which means like 1, and tell me the sign. Just the sign. I don't care about the number. I need the sign. Right. So positive was 1. 1 minus 2 is negative, so this is negative. So please pick a number between 2 and 8, any number you want. 8 is good, 5 is good, 5 minus 2, and 5 and 0.12. I only need the sign. Perfect. So now we are ready to make a decision. Between 0 and 2 seconds, the velocity and the acceleration are negative. They are working together. Although it's in the negative direction, we don't care. They are helping one another. So what does the particle do? Yes. Between 2 and 3, the acceleration is negative. But against it, there is a positive velocity. The velocity is negative, and against it, there is an acceleration that is positive. So what do you think happens between 2 and 3? Slowing down. Finally, both in the same direction from 3 to 8, they're both positive. What do you think is going to happen? Speed up. Any questions? Yes, please, no?
He wants to write the answer.
Exactly how we would with the table.
Oh, okay.
That's good
We don't
enough.
have to, like,
It's very clear. No, it's very clear to me that you selected here. Both are, they're helping each other, although it's in a negative direction. They're coming back. It doesn't matter. Here they're working against each other. So obviously the particle will be slowing down, and here they're helping one another again. They have the same direction. One is increasing the other. Any questions? Any questions? Yes, please. Eddie?
I have a problem sort of like that phase trig function, which goes.
Yes, of course, absolutely. You're talking about number 3. Yes, of course.
With, when a particle moves according to a law of motion,
Yes.
S equals f of t, 0 less than or equal to t, less
So
than,
yeah. So t is between what?
um,
8, 0, and
0 and
8.
8.
Okay. And the function is?
F of t cosine pi t divided by 4.
Perfect. Oh, so t is less than or equal to 10?
No, it's
0 to 8.
yeah. 0.
Perfect. Okay. Very good. Good. So which part of the problem you would like to, you want to do the whole thing?
Yeah.
Is this from web assign?
Yeah.
Okay, perfect. So what is the first question? Let's do what they are asking us to do.
Find the velocity. at
Very good.
time t.
Very good. So part A, we want to find the velocity. So the velocity is f prime of t. Can anyone give us the derivative of cosine pi t over 4?
Negative sign.
Very good. Negative sine pi t over 4 times. Excellent. So this is negative pi over 4 sine pi t over 4. Agreed? Good. Part B, what do they want now?
Velocity after 1 second.
Okay, so v of 1 is negative pi over 4 sine pi over 4. Do we remember how much is sine pi over 4? It's the only angle whose sine and cosine are identical. Excellent. Thank you. So negative pi over 4 times the square root of 2 over 2 is negative pi, the square root of 2 divided by 8. I don't know if they want an approximation. Are they saying anything or the exact? Do they tell us to round up? Or
It's, decimals, 2 decimals.
2 decimals. In that case, we have to plug it in, if that's what they want. Make sure that your mode is in radian. Careful, radian mode. Okay, and now we want, whenever you plug in sine, I mean when you plug something in sine, because it's pi over 4, in case you forgot the square root of 2 over 2. So this is negative pi, the square root of 2, and everything divided by 8. So that is, and you said 3? So remember, this is not a negative velocity. It just shows direction. So negative 0.555. And this is, are we given measurement units? I hope. Feet per second. Okay, perfect. Next question. What do they want now?
So wait, the velocity is not negative?
The velocity is negative.
Oh, I thought you said.
No, it means it's not negative.
It's
It's
just,
just the direction. Exactly.
Okay.
Yes. So if you ask me, you call me, I'm driving, and you say, what is your speed? I'm not going to say ever negative 40 miles an hour just because I'm going home. Right? Or negative because I'm coming to work. So it's not a negative number. It's just a direction. Yes. Next question. What do they want?
It was, again, the acceleration at t in feet per second squared.
Very good. So we have to differentiate this. We have negative pi over 4 times. We differentiate sine. How much? What is it? Very good. Cosine pi t over 4 times. Very good. So then we have negative pi squared over 16 cosine pi t over 4. And they want the acceleration after?
1 second.
1, very good. So again, negative pi squared over 16 times cosine pi over 4 is the same number. This is the only angle for which sine and cosine are identical. So again, I have to put in the graphing calculator. So let's see what we have. We have negative pi squared times the square root of 2. And outside we divide by 32. And we get negative 0.436, of course, in feet per second squared. Yes. What else do they want?
That was it.
That's it? Okay. Anything else? Anything else? Okay. So let's continue now with 3. We do not cover 3.8 in this class. It was covered in pre-calculus. So we jump directly to 3.9, related rates. Okay. Imagine we have a balloon and we pump air in the balloon, or a tire and we pump air in the tire. So what happens with the balloon? When we pump air in the balloon, the volume does what? Increases, correct. The radius of the balloon, if it's a sphere, right? Increases, correct. Okay, what else? The surface area increases. All these three are functions of the surface area, the volume, and the radius are functions of their time. They're all functions of time because we pump air in time, correct? We need time to pump air. So they all depend on time. Why do we call them? So they have a rate of change. There is a rate of change for the radius, there is a rate of change for the volume, there is a rate of change for the surface. Why are they called related? Because we will be able to find a relationship that connects them. Okay? So let's start with a simple example. I'll let you choose. Page 248. I would like to start with something simple, like, for example, number 5. A cylindrical tank with a radius of 5 meters is being filled with water at a rate of 3 cubic meters per minute. How fast is the height of the water increasing? Or the radius of a sphere, since I just mentioned that, is increasing at a rate of 4 millimeters per second. How fast is the volume increasing when the diameter is this? Or maybe we should start with number 6 first. Yes? Okay, so let's start with 6. So 6 on page 248. Let's read it one more time, and of course take notes on the information given here. The radius of a sphere is increasing at a rate of 4 millimeters per second. I'm going to ask you, what does this represent in a minute? How fast is the volume increasing? So what is the question? When the diameter is 80 millimeters. So first of all, we are talking about a cylinder. I'm sorry, we're talking about a sphere. So here's a sphere. And here's its radius. The volume of a sphere, and please remember it moving forward, 4 pi over 3 r cubed. This is the formula for the volume of a sphere. So what is given in the problem? We are told that the rate of change of radius with respect to time, the rate of change of radius, is 4 millimeters per second. So how do I denote this? Where I have the question mark, what is on the left-hand side of the equal symbol? So what do I write here? Over. But we're talking about time. It's seconds. Very good. So indeed, dr over dt is given in the problem, and that is 4 millimeters per second. That's the rate of change of the radius with respect to time. The question is asking us to find the rate of change of volume with respect to time when something happens. So what am I asked to determine? What do I write on this side? dV over dt, indeed. So the volume and the radius change at the same time. Okay. So I'm asked to determine the rate of change of volume when, which means this is the diameter equals 2 times the radius, which means that the radius is 40 millimeters. However, I just want to make a point from the very beginning. All this, do not cross it out like that. I'm just hoping that you will remember. This is for later. It cannot be taken into account at the very beginning of the problem because I need to find the derivative, and then I need to find a function, then its derivative, and then I plug in 40 millimeters. So I cannot start with that. That has to wait. Every time you look at the problem or you read a problem that says when, blah, 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 disregard the when till the very last step. Okay. So the question is asking us to find the rate of change of volume with respect to time. Where is my starting point? That's all I have. What will I do to it? What will I do to it? You may have said it, I didn't hear.
Just take the derivative.
Of course. Absolutely. What is the left-hand side? Keeping in mind that this and this are what? Functions of
Time.
Of course, it's very clear. When I'm given dr over dt and I'm asked to find dv over dt, they must be functions of time. If they're not functions of time, then what's the point of doing all this? Good. So the left-hand side is no, it's dv over dt. Let's be consistent. The other side is
4 pi over 3.
yes, because we bring down 3, right? 4 pi over 3 times 3, there will be 4 pi times,
R squared.
excellent, times,
dr.
indeed, of course, dr over dt, because they are functions of time, both of them. So now there is no problem. Now I can say when r equals 40 millimeters, because I'm done. I found the function, I differentiated it, and now I can plug in all the numbers. So I have 4 pi, I have 40 squared, and I have dr over dt, which is given in the problem as being 4. And then I plug in everything and I determine a number. Questions? So this is 16 times 40 squared and times pi, if you want to approximate. If not, just write it as 16 times 40 squared and not multiply by pi. So this is 25600 pi, or approximately to 80424.77, but I'm waiting for the measurement unit, without which makes no sense. Careful. We look at the beginning. This tells us the measurement unit. What is the measurement unit? What is the measurement unit? Something coming from the top and something coming from the bottom. What do we measure the volume in? Cube, right? Per second. Volume is measured in millimeters cubed, area in millimeters squared, and distance in millimeters. Any questions on this warm-up problem? Please, Noah?
What kinds of like related rates things, so like, do we need to know? So like the area of the
You mean
circle?
formulas?
Yeah.
So the area of the sphere, the volume of a sphere, the volume of a cone, we're gonna have several examples. Yeah, we're gonna go to a cone in a minute. And I'll explain what that is. So, why are these called related? Because there is a relationship between the two rates of change. One rate equals blah, blah, blah times the other. So this is the relationship between the two rates. They are related. How? They are related through this relationship. They are in the same equation together, so they must be related. And also, they happen at the same time. So let's look at, since Noah was asking about formulas, let's look at the cone now. So here's an example with a cone. So gravel is being dumped in this pile, which is a cone, And it says at a rate of 30 cubic feet per minute. Let's stop for a moment and identify what this means. 30 cubic feet per minute. What is that?
It's the volume, but it's
dV,
the rate of volume change.
dV over?
dt.
Perfect. So this is what we're given first in the problem. So this is 27 on 249. dV over dt is given as 30, and it is in feet, cubic, of course, cubic feet per minute. Okay. It says that it forms a pile in the shape of a cone whose base diameter and height are always equal. When it says always equal, it's not this piece that I have to wait for later. It's not. It says always. So the height equals the diameter always, which means I have to take this into account. This has to be taken into account from the very start. And the question now is asking, careful, it says, how fast is the height of the pile increasing? And I don't care about the rest at this moment, when the pile is blah, blah, blah. So after when, I don't care even to read just yet, because it's not going to come into play from the beginning. It has to wait. Is that clear? Am I clear with that? Okay, so how fast is the height of the pile increasing? What am I asked to find when the height is 10? What am I asked to find when the height is 10 feet? Which again has to wait. What am I asked to determine? dH over dt, of course. Awesome. That's the question. How fast is the height increasing when blah, blah, blah? Okay, so here's the volume of a cone. I'm going to talk about the cylinder first. And I hope that you will remember this. So here is a cylinder. The volume of a cylinder is area of the base, which is a circle, pi r squared times the height. Pi r squared times the height. The volume of a cone is identical, but divided by 3. So the volume of a cylinder is pi r squared h, and the volume of a cone is pi over 3 r squared h. So I like to present them together because they are so similar, and I'm hoping that you're going to remember them together. So the volume of a cylinder, pi r squared times the height, the volume of a cone, identical but divided by 3. So that's our starting point. So the volume equals pi over 3 r squared h. But we are given a very important piece of information that I have to make use of immediately, in which the height equals 2 times r, or actually r equals h over 2, because I don't have any information about this. That has to go. I don't know anything about the radius, other than the fact that the height and the diameter are the same at all times. So I don't want to have more than 2 variables. I have dV over dt and I have dH over dt. I don't need r. So I will replace it by h over 2. So then the volume is pi divided by 3 times h over 2 everything squared times h. Or pi over 3 h squared times h to the third divided by 2 squared, which is 4. Finally, pi over 12 h cubed. So all this effort was basically to get the function of the 2 variables related in the same equation. So we got that. So then what next? What will be my next step? So V equals pi over 12 h cubed. So let me not write more than one equal symbol for each equation so that it's not confusing. Okay, what do we do next? Yes, of course. We are using implicit differentiation with the idea in mind that V as well as H are what? Are excellent. Functions of time. Good. So then the left-hand side is? Very good. The right-hand side is? We bring 3 down and we simplify. So pi over 4 times times. Very good. H squared. Wonderful. Times dh over dt. Excellent. So we want to find the h over dt, so we're going to solve for the h over dt. This is the unknown now. This is known. It was given in the problem. So in order to solve for this, I will divide both sides by this quantity. So dh over dt equals dv over dt, everything divided by this, pi over 4 times h squared. So this is the relationship that relates the two related rates, the rate of change of the volume and the rate of change of the height. And now I can say, yes, it's okay when h equals 10 feet. And I can plug in everything. What is the top equal to? Very good. And this is pi over 4, and this is 10, which is squared 100. I will simplify. I will flip pi over 4, so I have 3 times 4, which is 12, divided by 10 pi. So let's approximate that. So I have 12. Be careful how you put this in. One option would be 10. No, it was not 10. It was 12 divided by, in parentheses, 10 pi. The other option is 12 divided by pi, and then continue to divide again by 10, or the other way around, it doesn't matter. But do not divide by 10 or by pi and then multiply by mistake. So we got 0.38. What is the measurement unit? 0.38 what? What is it? I think you said it, but I talked at the same time and I didn't hear.
Feet per second.
Of course. Of course. It's height per, which is measured in feet, by divided by time. Perfect. Any questions? Any questions? Okay. So let's look at number 15. Two cars start moving from the same point. One travels south at 60 miles an hour and the other travels west at 25 miles an hour. At what rate is the distance between the two cars increasing 2 hours later? So that's 15 on 248. So one starts here and the other one here. This at 25 miles per hour, this at 60 miles per hour. And we're interested in how fast is this distance. I cannot call it D because DD will be a problem. I'm going to call it either Z or W. Which one you prefer?
Z.
Z. So they start at the same point. One is going south at 60 miles per hour, and the other one is going west at 25 miles an hour. And the distance between the two cars is what we're interested in. And we want to determine the rate of change of the distance with respect to time. And it says when, which I don't really care right now, it says when t equals 2 hours. 2 hours later after the starting point. So what do we do? So the idea is to create an equation, right? I need to create an equation that involves the variable in question, right? And of course, it has to be related to what's happening here. I'm going to call this x, this distance x, and I'm going to call this distance y. And I know the rate of change of x. How much is the rate of change of x with respect to time? I know the rate of change of y, and I know that is 60. So I would like to determine the rate of change of z. So what is the question then? When time equals 2 hours, but that's of course much later. What is the question here?
dz by dt.
Of course. dz over dt, this is what we want. We want to determine the rate of change of distance between the two cars when blah, blah, blah. Okay, starting point. What do you think? We need an equation that relates something that I can use and differentiate and blah, 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 blah.
X squared plus y squared equals z squared.
Of course, Pythagorean theorem, x squared plus y squared equals z squared. That's the starting point, thank you very much, and the next step.
Differentiate.
Of course. Keeping in mind what? That x and y and z are what? Very good. They are functions of time. Excellent. Great. So please tell me what to write. Very good. Plus.
Plus 2y.
Yes.
dt,
Good.
2z, d.
That's it. Of course, I'm going to divide both sides by 2 to get rid of that and simplify it as much as possible. And remember, we are after which of these? Exactly, because these are given to us. This is our variable. And we have to divide everything by?
Z.
Excellent. So dz over dt, x dx over dt plus y dy over dt. We're not ready to plug in numbers yet. I do have this. Please tell me what it is. I do have this. Please tell me what it is. Awesome. But I don't have x, and I don't have y just yet. So let's find x and y. But now I have to relate that to 2 hours, because x will be a particular quantity 2 hours later. Y will be a particular quantity 2 hours later. And z will be a particular quantity, and I will take it from here by taking square roots. So this is the square root of x squared plus y squared. So, how much is x? 2 hours later.
50.
Yes. So the distance, which is x, equals rate times time. The rate is given to us as 25. The time is given to us as 2. So therefore, indeed, this number is 50, as well as this number, which is 50 squared. Perfect. Now, the same way we determine y. Can anyone give us y? It will be 60 times 2, which will be 120, and this will be 120, but squared. So I know this looks confusing, so let me write it one more time. So dz over dt when t equals 2 hours is 50 times 25 plus 120 times 60, everything divided by 50 squared plus 120 squared. And this is what we're going to put in the graph